Okay, let's look at 22. We're deciding if it's symmetrical with the x-axis, the y-axis, the origin, or none of the above. Okay, so let's go over what it means to be symmetrical with the x-axis. So symmetry with the x-axis means, this is a picture like such, and what that means is that for any x value, whether f of x is positive or negative, if the y value is positive or negative, it's gonna be symmetrical. And what I mean by that is the distance of what I go up and what I go down, no matter where I pick, is the same. Okay? And I mention this because if you can draw a picture, you don't have to like actually know specific rules, right? Just think about it visually. What does it actually mean, right? So symmetrical with the x-axis. And the word symmetry means that whatever you go in one direction, you go the other direction, and it's the same. Okay? So what does this mean in terms of the actual x and y points? Well, this means that whether x is positive or negative, we get the same y value. Okay? So if it's symmetrical with the x-axis, it doesn't matter whether you plug in a positive or negative x, you always get a... I'm sorry. What it means, I said that wrong. What it means is not that, but whether y is positive or negative, the x value stays the same. I said that wrong. Okay, so let me say that again. So whether y is positive or negative, the x value remains the same. Okay. Symmetrical with the y-axis actually means it's even. So I would encourage you, if you don't know what even means, to watch the previous video, which talks about what even means. But even is usually defined as f of x equals f of negative x, which is just a fancy way of saying whatever I go to the right or to the left, the y value is the same. Okay, so actually let me do it this way. Whatever I go to the right or to the left, so whether x or negative x, the f of x value, the y value, is the same. Okay? So with points, that would mean if I give you x comma y, if I make x negative, y is still the same. Okay? The origin is actually what an odd function is, and it's hard. I've always found it hard to visualize it, but it's essentially what is the definition of an odd. Again, watch the previous video if you don't know what the definition of odd is. Odd just basically means you switch them. So that's a negative sign there, and then you have a negative on the outside. So what does that mean? That means if you have x comma y, then if you make x negative, then y becomes negative. So if you had negative x comma y, then that would give you x comma negative y. Okay? So what does that mean? Okay? So the way I would approach the first one is, I know the first one is a parabola, because it's x squared, and you should have these memorized. We also know that that shifts the function up 3, and the negative means it's going down. So, and this is at the origin. My picture looks terrible, but this is from the origin, just shifted up 3. So the vertex is right here. So the vertex would be at 0, 3. So what do we notice here? Well, my artistic talent is terrible, but what that means is that when I went left and when I went right, I have to be going left and right the same way, right? We know a parabola is symmetrical with, or at least the parent function of a parabola, y equals x, is symmetrical with the y-axis, so whatever you go left and whatever you go right, it's going to be the same amount, right? Well, what did I do? I just took the parent function, I lifted it up 3, and then I flipped it, and so it's going to, of course, still be symmetrical with the y-axis. So that means that this is going to be symmetrical with the y-axis. That's the easiest way, I think, of doing it. However, you could also just simply plug in x, whether x is positive or negative, you're getting the same y value. So to remind you, whether x is positive or negative, you're getting the same y value. Okay. So in B, what I would do first is, let me just get the absolute value of y by itself. So this is x minus 4 equals negative absolute value of y, divide through by negative 1. So 4 minus x is equal to the absolute value of y. So there's a couple of ways of doing this. I think the most obvious is that the absolute value of y means that whatever I plug in for y, right, whether it's positive or negative, whether y is positive or negative, the x values stay the same, right? Because whatever I plug into this function right here, the absolute value of y, it's going to compute the same value, whatever the value is. It's going to be the same thing. So that means the x's are going to match. So what does it mean when the y's, if you change the y's, the x's stay the same? Symmetrical with the x-axis. So B is going to be symmetrical with the x-axis. Okay. The next one is a parabola. I know it's because it's x squared. It's a parabola. You can't assume just because in the first one, because it's a parabola, it just means it's going to be symmetrical with the x-axis, right? Why? Because if you have any sort of shifting left or right, it's not going to be the case. Okay. So one thing you could do is you could take y equals x squared plus 5x plus 1, and you could find the vertex. So the vertex is x equals negative b over 2a. And so this is going to be negative 5 over 2 times 1, which is negative 5 over 2. And this tells me that that this is not going to be symmetrical with anything. And I'd ask you to stop and think about why that's the case before I tell you why. Okay. So hopefully you've been able to figure this out on your own, but this means that the vertex is at negative 5 over 2, right? This means that wherever this parabola is, and I don't know exactly where it's at, I do know it's going up, and I know it's going up because this is plus x squared, positive x squared. I don't know exactly where this parabola is. Let's assume that it's right here. Okay. I know that it has to be doing this, which means it's no longer symmetrical with the y-axis. Okay. There's no way a parabola is ever going to be symmetrical with anything other than the y-axis, and I'll let you think about why that's the case if it's not already visible. Okay. So this is going to be neither because it shifted left and right. So remember, I just want to stress this again. Just because you see a parabola, I don't want you to assume that it's going to be symmetrical with the y-axis. Right? It's only symmetrical with the y-axis if you have vertical or if you're shifting it up and down by the same amount. Okay, so now we have an interesting function, x squared minus y squared equals 5. And we haven't played with this. We have played with x squared plus y squared equals 5, and we know that that is a, we know that is a circle, but I have no idea what's going on with x squared minus y squared. But I do know this, that whatever x or whatever y value, whether they're positive or negative, right, they become the same value. So x squared minus y squared they both produce positive values, right? So what that means is whether you put x as a positive, whether you make y a positive or a negative, or whether you make x a positive or a negative, you get the corresponding same values, right? So this function should be symmetrical with the x-axis and the y-axis. Okay? And what about if I interchange the x's and the y's? Well, no matter how we interchange it, we're always getting the same values. So this is also going to be symmetrical with the origin. Okay? And it leads to the question of what exactly does this function look like? So x squared minus y squared lends itself to what's called a hyperbola. And if you take more advanced math classes, you'll be exposed to this. But you can see here that from the origin, or rather, you can see that from the y-axis, no matter where I go left and right, it's always the same distance. We can also see this with the x-axis, right? Whether I go up or down, no matter what point I'm starting at, it's the same distance, right? Let me build some symmetry here with that. And it's also true, and again, maybe you can see it visually, I can't, that this value and this value, whatever value we pick here and whatever value we pick here, they're going to be the same as well. Okay, so a hyperbola is an example of a function that would be symmetrical if the hyperbola is at the center, right? I don't have any sort of shifting going on. That is an example of a function that would be symmetrical with everything. The other common example is a circle, right? So let me just say, like, let's say we have a circle, and it has to be at the origin, right? A circle at the origin, that would be the same, right? No matter what you go, whether you go diagonally or you go, if you take a point at the x value, you go up and you go down, or if you take a y value, you go left and you go right. Those are all going to still be symmetrical. So circles and hyperbolas are two examples of functions that are true for everything. So hopefully that makes sense, and I will see you in the next video.